Hello friend, in this video we discuss about some most popular machines used throughout the world. Induction motor being used throughout the world. Induction motor is simply categorized into two parts, single phase induction motor and three phase induction motor. Before we discuss about its working of three phase induction motor, I want to tell you some important properties of three phase induction motor. It requires less maintenance. It requires less expensive than DC machine of equal kilowatt and speed rating. Like if you go to the market and purchase a induction motor, then it will become less cheaper than DC machine. Frequent operation and then DC machine. Like a jerk will produce in the lift when we use DC machine, but instead of DC machine, if we use induction motor, then it will produce less jerks. In today's application, most of the lifts used DC induction motor. Application of induction motor: lift, crane, pump, exhaust fan, lathe, machine, and many more. Now we discuss about the construction of induction motor. Induction motor have two parts, stator and rotor. Stator is stationary part and rotor is rotating part. This is the winding of stator. I saw the stator winding in star connection, but it may be connected in delta. This is the block diagram of induction motor. A three winding is connected in the stator field. Right? It consists of cylindrical laminated core with slot nearly parallel to the shaft. Energy is supplied to the stator field. Energy is transferred to the stator winding through the electromagnetic induction, and hence such machines are called induction motor. This is simply called one on the principle of induction. A stator consists of three phase winding, as shown in this figure. Three phase winding which are placed slot are laminated here in the stator every 120 degree apart. A slot is made. Stator core is support. The windings are made from the coil, and each separated single phase winding insulated from each other and displayed space by 120 electrical and made as shown in this figure 120 degree. All the six terminals are brought out of the terminal box so that the operation can connect the machine in star or delta as per requirement. Now we discuss about the working of three-phase induction motor. The working of three-phase induction motor is very simple. The three-phase induction motor star is wound or three-phase balance winding and excited by two-phase balance supply. So stator field is rotating at a speed called synchronous speed. The maximum speed of an induction motor or any motor is a synchronous speed. Initially, rotor edge is stationary. I will show that in the waveform of three-phase winding. In this figure, I show that the three phase, right? This is called the red, yellow, and blue. This is the waveform of three phase supply. Three phase supply. This is called the three phase winding of induction motor. At starting when voltage applied to the voltage changes very rapidly at some instant. Here we say that at this instant the voltage of voltage of second winding is higher than with respect to the other two windings. At this instant the voltage is higher of red, means first winding is with respect to other winding. So this is changes very rapidly in this direction. The magnitude is changes very rapidly, like this wise. So we it is seen that uh, it is seen that in rotating field. So this is called a rotating magnetic field. That's why induction motor has a self-starting motor. It does not require any external motor or any external operation like prime mover connected. It can connect it to the supply and the motor will start. At starting, the relative speed called ns minus nr, ns called the same, ns called the synchronous speed, and nr called the ns called the rotor stator speed, and nr called the rotor speed. At starting, nr is equal to 0 and ns upon ns. This is called a slip. At starting, slip is equal to 1. But at the running condition, when nr reaches to the ns speed, then slip reaches to 2% to 3%. Due to relative motion, according to the Faraday law of electromagnetic induction, there are three-phase induced EMF in the rotor winding. As you see that in this figure, in the rotor winding are placed, and according to the Faraday law, an EMF is induced in the rotor winding. As rotor is short circuited, there are induced current in the rotor winding. First is an EMF is induced in the rotor winding, and then a rotor current is induced in the rotor winding. According to the Lenz's law, the direction of induced current will oppose vary cause of their production, reduce the relative motion, and also start rotating in the same direction. Like when static field is rotating, like in this way, rotating magnetic field is produced in the rotor, and this want to oppose its relative motion, and it also start to rotate in the same direction. As the rotor speed is always less than the synchronous speed, because at synchronous speed when it reaches to the synchronous speed, then the relative motion between rotor field and the stator field will be zero, and it will not produce any EMF or current in the rotor field, and the motor it gets slip. This is known as the slip. The formula of slip is S is equal to ns minus nr upon ns. This is the formula of slip. The rotor frequency. You see that in many books it is mentioned that rotor frequency so the secondary winding of the induction is any motor is similar to that of transformer, because transformer is work as same as that the induction motor, but the frequency is different, because transformer has a stationary part in the secondary, but induction motor has a rotating part. The frequency of primary winding and the secondary winding in the transformer is always 50 hertz, but in case of motors, induction motor, the frequency of rotor will be changes. Fs is equal to Fr is equal to Sfr. Fs. This is called the rotor frequency, and this is called the slip. This is called the stator frequency. As the slip is changes from 2% to 3%, the rotor frequency will be 0.02 into 50 hertz 1 hertz. So rotor frequency always very less than the stator frequency. Now we discuss the types of induction motor. The squirrel cage type, slip ring type, squirrel cage type and slip ring type. Squirrel cage type this is called the squirrel cage type of induction motor. This is the block diagram of squirrel cage type of rotor. In this, rotor bars are permanently short circuited. But at the rotor bars are short circuit having entering of the same material. Here the rotor bars are permanently short circuit, and they are short circuit with the same material like copper. and their shaft axis or screwed each slot. It consists of cylindrical laminated core with slots nearly parallel to the shaft axis or screwed. Because it reduces the tendency of cogging. Cogging tendency says that the locking tendency of the rotor is reduced. It means that rotor and stator teeth attracted each other due to the magnetic action, like called cogging. This is all about the case style induction motor. In the slip induction motor, the uh, in the armature head does not have permanently short circuited. Let me show the figure. The the conductor of the armature is connected to the end slip rings, and at the upper part of the slip ring, carbon brushes are connected to connect the external rotor resistance through which we can vary the speed of the induction motor. Now we discuss about some important question regarding to the SSC JEE mains if you are preparing. Like in question, it mentioned that uh, विंडेज लॉस इज विंडेज लॉ हम किससे निकाल सकते हैं? शॉर्ट सर्किट टेस्ट और ब्लॉक रोटेट टेस्ट. सो इफ this is the correct answer for block rotor test. Windows loss cannot determine through the short circuit test. In the short circuit test, we can determine the copper loss, transformation ratio, power scale of circuit. Power scale of circle diagram is a very important question for SSC. I always and 2 or 3 years ago when I give the exam of SSC JEE mains, in this a question is taken out that circuit is like induction motor, then what is the diameter called? So diameter called the current. An induction motor is switched on load. Torque of induction motor is directly proportional to the V square. This is the important MCQ question. If the average flux density in air gap is small, अगर हमारी फ्लक्स डेंसिटी एयर गैप में अगर स्मॉल होगी तो हम लोग गुड पावर फैक्टर अचीव कर सकते हैं. व्हाट इज द मीन बाय क्रॉलिंग? Crawling caused by hormones developed in the rotor sometimes exhibit a tendency. In the induction motor, it has sometimes exhibit a tendency to rotate a rotor at the 1/7 times speed than the synchronous speed. Then it is due to the crawling caused by hormones developed in the motor. At no loads in the slip induction motor, slip is generally less than the 1%. In medium size induction motor, generally 4%. Stator core of induction motor is made of silicon steel. Frame is made of cast iron. Shaft is made of carbon steel. Slip ring is made of phosphor bronze. An induction motor can run at synchronous speed. Yes, induction motor can run at synchronous speed, but when EMF is injected in the rotor circuit. डबल केज इंडक्शन मोटर, इनर केज क्या होता है? हाई इंडक्टेंस होता है, लो रेजिस्टेंस होता है. दिस ऑल अबाउट द इंडक्शन मोटर. नाउ वी विल डिस्कस अबाउट द नेक्स्ट टॉपिक इन द नेक्स्ट लेक्चर. थैंक यू एंड हैव अ गुड डे.